Welcome to Spring LIB.
Hi there. These cave paintings, they are calculated to be about 13,000 years old. And we know that the half-life of carbon-14 is 5,000 years old there. The half-life of carbon-14 is 5,700 years for the half-life. That means every 5,700 years, half of it will be gone. It will decompose. So we're looking at a graph there, and we are trying to figure out how much has decomposed to give us that 13,000 years. Well, it's a little tricky because we have a bar for 11.4 thousand years, and we have a bar for 17.1 thousand years. And the 17.1 is about 12.5%. Or is exactly 12.5%, whereas the 11.4 thousand years is 25%. So what we are seeing here, trying to interpret from this graph, is we see that the cave paintings are somewhere between, or they're somewhere between 12.5% and 25% of the carbon-14 remaining. Of course, our number of 13,000 is somewhere right about here. So we could try to estimate this, try to make it a line graph. That would make life a little bit easier. And we could try to estimate it from this, giving me approximately 20%. About 20% is the carbons remaining. That is just trying to read it from the graph. There is also an equation for half-life. And the equation for half-life says that the amount remaining is going to be equal to the initial amount times 1/2, and that 1/2 is going to be raised to the time that has passed, the total time elapsed, divided by the half-life. So we could use this equation to calculate a little more specifically how much is remaining there. So the amount remaining, I'm going to do this as percent. So we start off with 100% of this carbon-14. That's my initial. And then I need to multiply that by 1/2 times the total amount of time that has elapsed is 13,000 years. That's the estimate for the age of the cave paintings, divided by the half-life of 5,700. All right, so doing a little calculating here. 100% times 1/2 to the 2.28, because 13,000 divided by 5,700 is 2.28. Going ahead and calculating the rest of this, I get my amount to be, since I'm doing this as percent, I get 20.6. So 20.6% remains of the carbon-14. All right, so that's pretty close to my earlier estimate of 20%. This is just a little more precise. And the other part of this question wants to know in terms of parts of carbon-14 per trillion. Well, originally started out as 1 part carbon-14 per trillion. So if 20.6% remains, that means we have 0.206 parts of carbon-14 per trillion. All right, so there's our two answers, expressed as a percent and expressed as parts per trillion. Thanks for watching.